are going to finish up where we left off on page 165. So we did this kind of in a rush on Friday. So let's take a little time and look down here at our real world application problems. Okay? So this says, and remember, we were working with factors and multiples and patterns and rules on Friday, so this will kind of refresh what we were learning. So number 7 says, Amy lives in the 20th house on Elm Street. The first house on Elm Street is numbered 3. The second is 6. The third is 9. The fourth is 12. If this pattern continues, what is Amy's house number likely to be? So we noticed that they put this information in a little kind of like a sideways T-chart where they had the house and then the number or the address, right? So when we started this on Friday, we were first looking at patterns here from the numbers like 3, 6, 9, 12. But then we realized that they were asking us for the 20th house. And in order to do that, using this rule, add 3, Lana, we would have to have all 20 terms, right? A term is the number in the list. So we decided that we were going to look for maybe a pattern between the two pieces of data, the house, order, and the number. So that's when we kind of flipped our chart. So we had the 1 and the 3, the 2 and the 6, the 3 and the 9, the 4 and the 12. And we realized that if we looked at the data this way, we could actually multiply by 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. So then we did 20 times 3 and we got 60. Okay, so we're really just using the patterns in the numbers to help us fill in the missing information. Let's look at number 8. Oh, so the answer here for number 7, Amy's house number is likely to be number 60. Nolan, would you read number 8 for us when you're ready?
Can I also explain it? Or can I also solve the problem?
Sure, give it a try.
Theo runs 5 miles every morning. He tracks his progress on a chart to log how many miles he runs in all. How many miles will Theo write on the 100th day? He'll write 500 because obviously 5 times 100 is 500.
Wow, I saw that pattern so fast. So, Nolan, were you looking at the pattern between the terms here, or were you looking at the pattern between the columns?
I was looking at the pattern between the columns.
Tell us more.
Because in the day in miles, 1 times 5 equals 5, 2 times 5 equals 10, 3 times 5 equals 15, and so on. So if I got to 100 times 5 would be 500.
So 100 times 5 is 500. Did anybody else see that pattern? Okay, so this is just an easy way. We could have computed all of this, but when we look for patterns, it can make the math easier. So what answer would we write? How many miles will Theo write on the 100th day?
500 miles.
500 miles. Are you with me, Ryan? Did you write down an answer?
You're talking Ryan.
Okay. Yes, no, Miles, we're going to turn the page. Did you have a question?
Would it work on the housing numbers?
Yeah. We can write it in like this. 1 times 3. 2 times 3. 3 times 3. 4 times 3. And 20 times 3. Yeah, right? I know, because you were gone. We'll catch you up, Lucas. We'll catch you up. Yes, Nolan?
I did these pattern things in the OLSAT test.
Yes. Yes. Because seeing patterns is something that is just like some of our brains see them one way, some of our brains see them the other way, and some of us don't really see them and it makes it hard, but that's okay. Okay, so let's look at this. Now we're looking at actual patterns. So remember I talked about kindergarten when you use the linker cubes, right? Red, green, red, green, red, green. So this is kind of like that, not using numbers. We're using shapes. And instead of colors, we just have really like filled in and not filled in, okay? So we're looking for the repeating terms. So in order to do this, now that our patterns are more complicated than kindergarten, we have to look down the pattern to see kind of where it restarts. This is the strategy that I use. So if I've got like an empty square, a filled in square, a filled in square, a triangle, an empty square, a filled in square, a filled in square, a triangle, where do you see the pattern starting again? Ella? The end of the first triangle. So this is almost like we've got 1, 2, 3, 4 terms in the pattern, and then the pattern repeats. Do you see that? Yes? Cash? Yes, square, 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 triangle, square, 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 triangle. Yes, So the repeating terms of the pattern is this group that happens every time we go along. Annie?
I kind of see it like black square. I mean, white square, black square, triangle, white square.
Yes. So here are the repeating terms. We're going to just copy down this first little section, the part that repeats. So we've got an empty square, 2 filled in squares, and an empty triangle, right? Because the next time the pattern occurs, those 4 terms are going to repeat themselves. Gunnar, did you have a question about that?
For a second, I thought it stumped me for a second there because when you talked about the triangle, I was like, is there more patterns to this? But then I realized in the middle it showed triangle and then the same thing, so that made me unconfused. Okay.
And you could use words to describe the terms. Also, you could have said white square, black square, white triangle. Okay, so what will be the 10th term in the pattern? Any ideas? Let's see, how many terms do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So this is asking for 9 and 10. How could we are really wanting to know what will be here. Lana, can you tell us what you think and why?
So for 9, it's going to be a white square, and for 10, it's going to be a black square because after a triangle, they're going to repeat the white square, and then there's going to be a black square.
So I love how you said because after the triangle, the pattern will repeat. So we know that the 10th term in the pattern, and you could draw it in or you could say it will be a black square. Oops. Yes, Nolan?
And the 15th pattern will also be a black square.
Oh. 13, 14, 15. So one thing I could note is there's 4 shapes before the pattern repeats, right? So I've got 4
But it goes white square.
and 4 and 1, 2, 3, 4. And then this would be the beginning of my next pattern, right? So if this is 10, 11, 12, 13, 14, 15, this would be my 15th term. And I know my pattern would repeat. So I would have white square, black square, black square. So this doesn't really feel like math because we're not using numbers, but these patterns do use that same side of your brain that you use for numbers. So our answer for this one would be black square. Now, sometimes patterns don't look like shapes and they're more like blocks. And these can be challenging. So dig in because it's going to be fun, but it might not be easy. So we have to figure out, just like when we were looking over here at the rules and what happens from one to the next, we have to figure out what is happening between this tower and this tower. So a possibility might be what? Cadence?
Possibly for the whole thing is like
What if we're just looking at this?
2 plus 2 is 4.
Okay, so that it could be they're adding 2. Okay,
Or multiplying.
tell me more.
Like 2 times 2 is 4, and then they can do 4 times 2.
Ah, okay, so that's where it's hard, Jackson, to decide what's happening when you just look at 2 terms. So Gunnar, we're gonna look at the next term and figure out, did either of these rules work? Did they add 2? Did they multiply by 2? What do you think, Alex? Are we adding 2 more boxes on top, or are we multiplying this whole shape by 2? We're multiplying the whole shape by 2. The adding 2 doesn't work anymore, right? Because we actually got 4 more. Okay, but we didn't get 4 here, so we couldn't be adding 4. So maybe we're multiplying by 2 because we had 4. Now we have 8. Let's see if that works for this next pattern. So I'm going to circle the new part. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 original. 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 new. So does the times 2 work, Nolan?
Yes.
Okay, so here we're gonna multiply or basically double our tower. Okay.
The way that I saw it is like, the 4th square was also just 2 squares, except it took the other 2 squares, and then the other 4 square took that 4 square, so now it's 8 squares, and then the 8 squares took the other 8 squares, and so now it's 16 squares.
Yeah, and you could also, like, what if we say,
3 plus.
here's our original. And then when we go to the next one, if we colored in the original, we could say, okay, I can see how we just doubled what we had, right? Now, if I color in the original, my 4 that I started with in this term, I can see, oh, now I've got it doubled. And if I color in my 8 that I started with here, I can see, oh, now I've got it doubled. So how would you use words to answer this question? How does each figure in the pattern change from one term to the next? What words would you use? Gunnar, how would you describe that?
What I described is multiplying and adding it to each other.
So tell me more.
Okay. What I'd add to it was multiplying itself to add it to be taller to do then multiply itself again.
Okay, so maybe you're like multiplying the original number of boxes by 2 and then adding it to the top?
Yeah, and then multiply it by that again.
Okay, because they're definitely growing up, right? Okay. Yes, Cadence, how would you describe it?
Pattern changes because it's multiplying, like 2 multiplying by 2 and it's making 4, and then 4 times 2 equals 8, and 8 times 2 is 16.
Yes, that's great for the number of boxes, and then maybe you wanted to add the fact that the tower grows taller each time, right? Thank you. I like how you use part of the question in your answer. Chase? Khalid, you want to explain it?
I think
multiplies by 2 each, all the things, but it's not. It doesn't go by 2. It doesn't count by 2.
Right, right. We're not adding 2 more, huh? We're adding 4 more. Yeah? Okay, I'm going to give you a moment to answer this question to your partner out loud. How does each figure in the pattern change from one term in the to the next? I want you to tell your partner. I want you to hear what your partner says, and then I want you to write down your answer. Get it? 3 things. Say it, hear it, write it. Go. I'll listen to you.
It adds the previous squares on top. Already helped me out on it.
So there's
Okay. Are we multiplying it times itself or are we multiplying it times
1 times 2. It's like
That's smart. Okay, and for this, they multiply the pieces by 2. Yep, they do. And then the next one is going to be 36.
How would they grade?
36 times 2.
How would they grade 170 in under
72. The one after 36. Let's see. 1, 2, 3, 4, 5, 6. One more. Okay. 72. Describe the number 2 I never
Did you write your answer, Nolan? Yep, I see it.
Okay, the answer for this is 146. How do you know that? I did the problems.
Okay. I love how Jackson said it doubles itself. Because you know that when we multiply something by 2, we're doubling. Okay, so that's another way of saying we're multiplying each stack by 2. Okay, guys, remember when I'm talking, you should not be talking. Okay, now we're looking at describe the number of squares in the next term in this pattern. So what would the next term? Remember, the term is like the shape or the number or whatever the pattern is repeating. Miroslav, what would you say?
So basically, if 16 times 2 is 32, so it's 32 squares.
So we would have,
16 times 2 equals 36.
oh, 36, you're right. 16 times, no, it's not, it's 32.
Wait, it is?
Yes, 6 times 2 is 12. So we would have,
Oh, yeah, I made a mistake.
it happens to the best of us. So we would have 32 squares in all, right, Miroslav? And then maybe we would say like
That answer was not.
stacked. Sweetheart, if you need to say something, raise your hand.
I was just telling my partner.
What was that, Miroslav?
Is that on top of each other?
Yeah, stacked on top. Maybe in rows of 2. Because we're not going to have 32 squares like this, right? We're going to have 32 squares like this. Rows of 2. Excellent job, Miroslav. I'm not going to draw it because that's a lot of squares. Okay, so take a moment, and you don't have to write these exact words, but I want you to describe the pattern for the next one. And I didn't use words, I used the mathematical equation that Miroslav said. 16 times 2 is 32. So we established our rule.
Okay, so this is 128. How do you get that so fast? I do all the problems.
What he gets so fast?
Math problems. I got the answer.
Okay, then you only have to do it for 2 questions.
Wants us to keep him
Okay, now we're looking at circles. Nolan, ready? How does each figure in the pattern change from one to the next? So take a moment and talk over with your partner. What do you see happening here with these circles? Go.
We already did this, so we don't.
Did you talk to Abby?
We already did this.
Did you already talk about it?
Yes.
Great. Just gonna give you 1 minute. Cash, did you tell Kaden? Now listen to him. Don't tell me. Write it down. So top and then right.
Are you okay?
Is the repeating
How many equal parts will there be? That's my favorite. In the 7th term. What was the answer again? 122. You sure? Okay. If it's not, I'm blaming you. 128 equal parts. I forgot to change the 124. Okay. Okay. What? I need to be calm. That's weird. You stop it. What is that laugh?
Yes, Matthew? Yes.
905.
Yes. Yes. Yes, Matthew. Okay, so class.
Yes.
You clap and then you look. Okay, I'm hearing some really great discussions, Lana. We were just counting, Matthew was kind of counting the number of slices, and I heard Lana say, oh, it's like pizza. So we have just one big slice, would you agree? And here we have 2 slices, would you agree? And here we have 4 slices, would you agree? And then we have 1, 2, 3, 4, 5, 6, 7, 8 slices. Would you stop with the sounds, Nolan? It's hard for people to concentrate. So then I heard this group, Tasha's group was saying, or maybe it was Miles, it's kind of like the squares were multiplying by 2. And so I asked, but is the circle getting bigger? Right? Our stack of squares was growing bigger. The pieces were getting more pieces, so the number of pieces is growing bigger. But nothing is actually changing about the size of the circle, right? Yes, Zachary.
So the slices are growing smaller, but the number of slices are growing bigger.
Yes, that was brilliant math talk right there. The slight number, say it again.
The number was going up, but the size was going down.
Yes. What does that make you think of? Fractions and pizza. Mm-hmm. So what should we write? How does each figure in the pattern change from one term to the next? Maybe the number of slices is doubling, right? Do you remember to raise your hand if you need to talk? So how many equal parts will be in the 7th term? Let's see. This is 1, 2, 3, 4, 5, 6, 7. How could we figure out How many slices will be in the 7th term? Any ideas? I don't want to draw all these circles. What could I do, Kate?
Well, I doubled the fourth one.
Okay, so how many slices would you have here?
Then there would be 16.
Okay.
And then since that would be 8 times double, and it's only 7.
8 times 2.
Take away 2. And then there would be 14 slices of equal parts.
I missed that part. So I agree that there would be 16 slices for this one.
Yeah.
Then how many slices would there be in this one? Want time or help? Abby?
32.
32. Anyone agree with Abby that there would be 32 slices in this one? Because we did 16 times 2. And then what about in this one, Liliana? Does anyone agree with Liliana that this would be 64? Okay, so how many equal parts will be in the 7th term? 64.
I forgot the 16. Sorry, Abby.